In the previous video, I talked about the first type of transformation, which is translation. And we looked at how graph changes when we add a number or subtract a number from or to a function. So for example, if we have the square root of x, and that's the function, what I did in the previous video, I make a table and I pick points, pick numbers for x and to get y, so I can get points. Like for example, 0, 0, 1, 1, and 4, 2. But again, if you have a graphing calculator, you can use that to help you. And there are also, if you don't have a graphing calculator, you can just go online and just search graph functions. You can find lots of websites that can do that. So I just put square root function here. That's what we get. That's what we get. And so if we take this whole function sqrt square root of x, and I'm going to add a 2 to it, and so you can see the graph is shifted up, is moved up 2 units, which was explained in the previous video. Why it's shifted up, because we're adding every y value is added 2. And so that's why it's moving up. Similarly, if I change it to -2, you can see it's moved, the graph is moved down because every y value we have, say 0, we got to subtract 2 from that, we get -2, and 1, subtract 2 from that, we get -1, and so on. Okay, so that's kind of can help you understand, by looking at the graphs, understand what the values, why we are shifting graphs up or down. Also, we have some other, for example, if we do parabola, so I didn't do parabola, if we have x squared, and I could add it to x squared. If I subtract 2, as you can see, it's moved down, but if I change it to +2, and the graph is going to be moved up. Okay, that's the first translation. But the second one, we kind of looked a little bit. So instead of, notice that I'm adding 2 to x squared to the square function. But if I move this +2 into the base, so I'm going to add it to, by the way, we need a parenthesis. If we don't have parenthesis, the graph is not right. So we're going to add it to only to x, not to the square. As you can see, the graph is moved to the left. But if I subtract 2 from x, the graph is moved to the right. So this is also translation, but instead of up and down, it's to the left or to the right. So what you can call a horizontal or vertical translation. And I also explained in the previous video why that is, because, for example, x -2, and in order to get the same y value 0, we have to make our x pick a 2 for x, because 2 minus 2 is 0, and 0 squared will give us the y value 0. That's why. And we got to move this point from 0 to x equal to 2. And similarly, if we change that to x +2, in order to get a 0, we have to have -2 for x, because -2 + 2 is 0. So that tells us to move this point from 0 to -2, to x equal to -2. Okay, so that's the first type of transformation, which is called translation, either horizontal or vertical. So remember the difference for horizontal, left or right, we're adding the value or number to only x. So that's what we have right now. But if I want to move the graph up or down, I'm going to have to add a value to the entire function. So I can add a 2 or 3 or subtract 2 or 3 to the square function. So that's the difference. Okay, so let's go back to continue to look at the second type of transformation, which is called reflection. All right, so reflections, we also have 2 types. Well, previously we're talking about either it's always add or subtract. So you can add a number to the whole function, to the square, or to the radical, or you subtract. But this time we're doing multiplication. So if we multiply, let's say the second one is multiplying x by -1. So we know -1 times x is going to be negative x. Or the other way we could do is we could multiply the radical function by negative, so that we also have two possible ways to do it. Okay, so the main difference between these two functions, in this function, we're taking the function f of x, which is a radical, and multiply by -1. But in this function, we're not taking f of x, we're not taking the square root of x. We keep square root of x as positive, but we're going to change x from positive to negative, which means -1 times x. So similarly, in here, I kind of had backwards, but so this one is we take the square function, not radical, and multiply by -1. But right here, we're only taking x and multiply by -1. So we always have two kind of things. Doesn't matter, it's addition, subtraction. You can always add a number, say add a 2 to the square function or the radical function. But you can also keep in the square, not adding anything to it, but you could only add or subtract a number from or to x. Okay, so this time we're doing multiplication, and let's see how the graph changes. And we can again go back to the previous function, which we did. So we always start with the basic function, square root of x, and that's what we got before. If we multiply square root of x, the entire function, by -1, so notice that every y value, so this will change the y value we got before. So that was our value, y value. Every y value will be multiplied by -1. So 0, if we multiply by -1, we still get -1. But if we have, change the color, if we have, so originally we had a point 1 and 1. But this time, the y value 1 is going to be changed to -1. So we're going to get a point here. And then for 4, we got a y value equal to 2. But this time, because we have to multiply the 2 by -1, that gives us -2 down there. So if we join these points we got, by the way, 0, if you multiply by -1, you still get 0. That's why this point doesn't change. But all the others, as you can see, all the other points will be flipped down to the bottom. So they are symmetric about the x-axis. So we call this x-axis reflection. But what if we, so let's start with the square root function. And if we change, so this one, what I just draw, this is y equal to square root of x, but this one is y equal to negative square root of x. And then still we start with y equal to square root of x, but this time we're going to change x to negative, not y to negative. So notice that, and we are going to we can make a table. X, Y. So this time, notice that so I'm drawing y equals square root negative x, and notice that again we have to pick. We can still pick 0. -0 will give us 0, but we cannot pick 1 because square root -1 is undefined. But we can pick -1. And notice that if we pick -1 for x, -1 will give us +1, and the square root of +1 is equal to 1. So now we can only pick negative values for x. So we can pick -4, that gives us square root of -4, that's square root of 4, which is 2, and so on. So this time, notice that again, previously we picked 0, 0, and 1, 1, and 4, 2. This one is 4, 2, and this one point is 1, 1. But this time we're going to have to change all the x values from +1, +4 to -1, -4. So again, you can see after we sketch the graph, it's going to be symmetric about y-axis. So we call it y-axis reflection. So it's like sort of like you flip this one down, or you flip this one to the left, depending on whether we are multiplying the value between multiplying y, the -1, multiply -1, the entire function by -1, or we multiply only x by -1. So the quick tip is, if we multiply entire function, which means y, and you're going to have to flip all the y values and from positive to negative or negative to positive. But if we multiply x by -1, you're going to change all the x from positive to negative or negative to positive. So that's why it's left to right, or y reflection. So now we're going to look at the last transformation. It's called vertical stretching and shrinking. So this time what we're going to do is we are going to, previously we multiply by a -1, but what if we want to multiply by a number like say 2? So I'm going to take x, the function, the entire function, square root of x, and multiply by 2. Or I could take the function, multiply by 1/2. So let's see how that changes the graph. And notice that if I multiply radical x by 2, this is square root x. And again, the points we got was 1, 1, and 4, -2, 4, 2. Notice that if we multiply radical x by 2, all the y values will be doubled. So this one will become a 2. This 2 will actually become a 4. So when we can pick the same x value, but the y will be doubled. So this point actually from 1, x equals 1, y equals 1 becomes x equals 1, y equals 2. X equals 4, y equals 2 becomes x equals 4, y equals 4. So as you can see, the graph, it's sort of like, it's like widened. It's more like, so it's like we stretched it. What if we multiply by 1/2? If we multiply by 1/2, and instead of doubling it, the 1 with multiply by 1/2, that's going to give us 1/2. And again, the 2 will divide by 2 will give us a 1. So actually the graph is going to be like shrunk. And for radical x, it might not be very straightforward, but if we look at it, may not be easy to see how it's shrunk or how it's stretched. But if we look at a parabola, it's much easier to see. So if I double the square function, every value will be doubled. Okay, so previously we got 1, 1, but this time 1 we will get a 2. So it's actually gonna be if we multiply by 2, when we look at the function f of x equals x squared and f of x equals 2x squared multiplying x squared by 2, and notice that when we pick 1 for x, we get y equal to 2. So the graph is actually stretched vertically. It sort of becomes narrower, but that concept usually cannot be used for other functions. And now, what if we multiply by 1/2? If we multiply by 1/2, and 1 will become, this y, 1 will become 1/2. So that's going to be right. It's going to be down here. And as you can see, the graph actually becomes wider. What we usually say, we said it's a vertical shrinking. All right, so we summarize all of those here. That the last one we went over was vertical stretching and shrinking. There's another one we could multiply a number x by a value like 2 or 1/2, which is going to be like horizontal stretching or shrinking, which we omit here. So it depends on whether the number we're multiplying is bigger than 1 or it's a number between 0 and 1. It's usually if it's a bit bigger than 1 for vertical stretching, and it's stretching vertically in y direction. Otherwise, if it's like 1/2 between 0 and 1, it's going to be shrinking it vertically. And also we had translation and reflection.